Hello and welcome back to LearnLinuxTV, and also welcome back to the OpenStack series here on LearnLinuxTV. In this particular series, I'll teach you guys everything that you need to know to manage a real OpenStack implementation. Now, in the previous episode, I covered compute, and this time around, we're going to take a look at storage within OpenStack. And with storage being one of the most important fundamentals when it comes to any data center, this is definitely an important episode. But before we dive into that, I need to take a moment to mention a really awesome sponsor without which this series wouldn't be possible. And of course, I'm talking about OpenMetal. And OpenMetal is awesome. With their platform, you could get set up with your very own on-demand private cloud. And what that means is that they could set you up with an OpenStack implementation of your own. If you've worked through the process of setting up OpenStack yourself, then you might know how time-consuming that can be. But that's not a problem with OpenMetal, because with their platform, they'll provide you with an OpenStack cloud of your own, so you could get up and running with OpenStack a lot quicker than you would otherwise. And what better way to introduce OpenStack into your organization than to partner with a company that not only adores the technology, they live and breathe it. And that's not all. When it comes to OpenStack adoption in general, OpenMetal is all about raising awareness when it comes to OpenStack and sharing their love of OpenStack with the community. So if you want to try out OpenStack in your organization, then OpenMetal is a great way to get started. So definitely check out OpenMetal. You'll be supporting the channel by doing so, and you'll end up getting your very own private cloud, your very own OpenStack cloud, and that's awesome. Now with all of that out of the way, let's dive back into OpenStack for episode 3 and check out storage. Now before we get started though, let's go through a quick refresher of some of the concepts that we've gone through at this point in the series. So far, you've learned that OpenStack is a solution that's best used with multiple servers. This allows you to scale out the individual components of OpenStack as needed as your organization grows. But for most of you watching this video, you probably have a single server with all of the required OpenStack components installed on it, which may not be great for production use cases, but is absolutely fine when it comes to learning and evaluation. Also, we took a look at the compute side of things. Nova is the name of the service that provides compute resources. So basically, you could think of Nova as the OpenStack project that takes care of virtual machine instances, or more simply, instances. We also looked at instance flavors as well, and these flavors help us define the resources that are made available to our instances. If you're unfamiliar with any of those concepts, then it might be a good idea to watch the previous episode to get yourself up to speed. Anyway, as I mentioned, this time around we're going to take a look at storage. And yes, you guessed it, that also means looking more closely at yet another member of the OpenStack family of services. Specifically, we'll be working with Cinder, and that's the name of the service within OpenStack that handles storage in general. So let's take a look at Cinder. We'll do exactly that in the next section. In the previous video, we used the OpenStack dashboard to create resources. That dashboard is provided to us by Horizon, and as you already know, Horizon is the dashboard component of OpenStack. It's responsible for the entire interface when you connect to the web console. Now, when we created our instances, we did so within the compute section, and that's where I am right now. And within that, as you can see here, we have an instances section. And if you've already gone through the second episode, then this should look very familiar to you. On my end, I already have a few instances here. When we created those instances within the dashboard, Nova took care of setting up those instances as we've instructed it to do through the dashboard. As part of the process of creating those instances, one or more virtual disks were also created. Just like with physical servers, our instances need some sort of storage. On a physical server, you'd install a hard disk to serve as the primary storage for that server, and that hard disk generally includes the operating system. But here in OpenStack, when we launched a new instance, a new storage volume was created for us automatically. We saw this initially when we chose the flavor of our instance. As I mentioned during the previous episode, the flavor determines what resources our instance will have access to. For example, how many CPUs are available, how much RAM the instance has access to, and also how big the primary disk happens to be. Here on the Horizon dashboard, if we go to the volume section, then we take a look at the volumes that we have here, you can see that we already have some storage volumes. We have two right here. There's one right here and another right here. Now, if I wanted to create another volume, I would do so by clicking this button right here where it says Create Volume. However, at this point in the series, I have yet to click that button even once. But we do have a few volumes here already, so how did we get those? Well, one potential clue is that we see a status of in use for both of these volumes. So I didn't create these myself. They're already here, but they're already in use by something. But what exactly is using these volumes? So to figure that out, I'll click on one of the volumes. I'll just randomly choose the first one right here. And if I scroll down, we can see that this particular volume is attached to an instance with the name of blog-prod-1-restored. And actually, that's the name of one of the instances that I have in the Instances tab, and that's not a coincidence. So if I click on that, and then look down here at the bottom, we can see that we have an instance ID that's attached to this instance. And if I click on that, it brings me right here to this particular volume. So it brought me back to the volume section. So if I didn't know any better, I would actually assume that this is the main storage volume of this instance right here. And actually, that's exactly what it is. So anytime we create a new compute instance, we automatically have a volume created for that instance as well. That makes sense. All servers, even virtual servers, need a hard disk. An operating system is needed, and we also need a place to store files, install applications, or do any of the other computing tasks that you would normally do on a server. Obviously, storage is required and it's very important. So, as you can see here, anytime we set up a new instance, we also get a new volume as well. That volume will be created from the image that we chose during the setup process for that compute instance. However, we're not actually limited to the main storage volume that's created anytime we set up a new compute instance. We can add additional volumes as well. And this is actually common because when you have an application that you're serving to the public, and that application needs, well, a lot of storage, then it doesn't make sense to share that with the main storage volume. If the main storage volume becomes full, for example, that can cause the entire server to come grinding to a halt. However, if you have all of the important data on its own volume, sure, that volume can become full in and of itself, but that won't cause the entire server to have a problem because the main storage volume is separate. So by separating the data that we have on our server, we can have more control over the, well, stability of that server. And we could also determine how to logically split up storage as well. So we could use our creativity as administrators to set up volumes for our instances that make sense according to the use case for that instance. In fact, let's set up a new volume right now. So like I mentioned earlier, we have a Create Volume button right here. So I'll click on that. And what I'm going to do is actually provide a new volume to one of the instances that I've already created. So hypothetically, we could just assume that our blog instance is going to utilize some extra storage. And that makes sense. If we are creating blog posts, then we might have images, maybe video clips, that can really add up. Now, obviously, our blog instance is just a hypothetical instance. It only has Apache installed on it right now. But that doesn't really matter so much. The example is if a situation comes up where you need additional storage, I'm going to show you how to add additional storage to the instance. So what I'm going to do is give it a name that helps me match it to its use case. So I'll just name this one blog data, just like that. And then for the description, I'll give it a clever description. And we can also create a volume from a source. So for example, I could choose a snapshot, an image, and so on. But what I want to do right now is just create an empty volume. So I'm going to just leave that selected right there. For the type, we only have the default option for now. And then when it comes to the size, there's no right or wrong answer when it comes to how much size to give the instance. You basically want to make sure that you have enough storage for whatever you're going to be using that particular compute instance for. My personal suggestion is to always give it a little bit more, just in case, well, the files are bigger than you expected. Maybe your blog becomes more popular than you accounted for. Sometimes it just makes sense to have extra space, but always make sure that you're within the confines of the hardware that you have OpenStack installed on. In my case, though, I'm just going to give it 16 gigabytes. That's really small, but I think it's good enough for the example. Now, when it comes to the availability zone, I'm going to leave this on the default right here, which is Nova. You can have additional availability zones, and if you do, you want to make sure that you create the volume within the availability zone where the instance that you want to attach it to is stored. If you create it in a different availability zone, then, well, you won't be able to attach that volume to the instance. I only have one availability zone anyway, so I'm going to leave that at its default. For the group, I'm going to leave that at its default of no group. There's no volume groups created at this point. Now, before I click the button down here to finalize the process, we want to make sure that we're within the limits for the implementation that we have here. And we don't need to just be within the limit, we also need to be within the budget as well. We want to make sure that we don't provide an instance too much storage to where other instances that also need storage won't have enough room. As an administrator, you just want to make sure that you're allocating enough storage to your instances. I'll leave that up to you. But anyways, since this is just a hypothetical example, I'm just going to continue along and create the volume as it is right now. Now, as we can see right here, our volume has been created. And yeah, that was all there was to it. We created a volume. It was that easy. Now, to be fair, we're not completely done yet. Yeah, we have a volume, but in order to use it, we need to set it up. And one of the things that we're going to do first is attach it to an instance. So what I'll do is click on it. Then here on the overview, if I scroll down, we can see that it's attached to, well, nothing. It's not attached to anything at all. And that makes sense. I've just created it, so I haven't had a chance to attach it yet. So what I'm going to do is just click this down arrow right here. I'll click Manage Attachments. And we can click this drop down right here to select an instance to attach this volume to. And what I'll do is actually attach it to this instance right here. It really doesn't matter which one we choose. So I'll just click on that. And then to finalize the process, I'll click Attach Volume. And now, as we can see, the status has changed to in use. We could also see that the device name on the instance itself is going to be /dev/vdc. So we should look for this on the instance itself, so that way we can set it up. In here, I'll paste the command that we used last time to connect to this instance. And here it is. And there's nothing new here. I've already gone over how to connect to an instance in OpenStack via SSH. So what I'll do is press enter. And now we're logged in. Now, as you recall, I attached the new volume that we created to this instance. And if I run the lsblk command, you can see a list of storage devices that we have here on this particular server. At the very bottom, we have VDC. And that's actually the disk that I created earlier. It's 16 gigabytes, so the size matches, and VDC matches as well. We want to make sure that everything matches when we work with storage volumes. Now, VDA, as we can see above it, is the main storage volume for the server. On that virtual disk, we have 3 partitions. We have VDA1, VDA14, and VDA15. But we don't have anything like that underneath VDC. And what that means is that we actually don't have any partitions at all on that disk. And the reason why that's the case is when you create a volume within OpenStack, then it's basically the same thing as buying a brand new hard disk or a physical hard disk and plugging it into a server. And then on the server, you have to create a partition, you have to format, you have to set up that storage volume or that disk for use. And we have to do the same thing here in OpenStack as well. But that's actually really easy to do. So let's work through the process. And there's multiple ways of creating partitions and formatting on a Linux system like this one. So I'm going to show you the method that I use. I know it might seem old-fashioned, but what I like to do is utilize fdisk to create partitions. And the disk that we want to work with is under /dev and then /vdc, just like that. And how exactly did I know that the path to the device was /dev/vdc? Well, if you recall, here inside Horizon, when I scroll down here to the bottom, we can see that the path has been set right here, /dev/vdc. So that's how I know that we need to work with /dev/vdc. The fdisk command isn't specific to OpenStack. It's just a utility that we can use to set up a storage volume, or basically manage partitions on a storage volume. Again, there's other methods and commands that you could utilize to create partitions, but I'll go with fdisk on my end. And anyway, I'll press enter to get started. And now we are actually utilizing fdisk. Now, a complete walkthrough of fdisk is beyond the scope of this video and even this entire series, but what I will do is go through everything you need to know when it comes to utilizing fdisk to create a partition on a volume that we intend to use with OpenStack. And in fact, there's nothing different here when it comes to setting up a storage volume in OpenStack. At this point, we do it the same way that we would do it on any Linux system. Now, what we could do with fdisk to get started is we could type p for print. What that'll do is show us the current partition layout for the disk that we're currently managing. Right now, we don't have any partitions at all, like I mentioned earlier, so I didn't expect to see any here, but it's always good to make sure that we're working with the right disk. Anyway, to create a new partition, what I'll do is type n, short for new. And what that's going to do is trigger fdisk to ask us some questions regarding how we want to set up the partition. I'm going to leave the first selection at the default, which is P. We want to create a primary partition, so I'll just press enter. And now it's asking us for the partition number. We don't even have any partitions yet, so I'll leave the default of 1 for this choice. Now when it comes to the first sector, there shouldn't be any reason for us to edit this. Advanced administrators might have a reason to edit this, but for our purposes, we're just going to leave it at the default. And that's what I recommend that you do as well. Now for the last sector, I'm going to simply press enter here as well. If I press enter here, then that means the partition is going to take up the entirety of the disk, and that's what I want. Now on your end, if you wanted to create multiple partitions, just know that you can do that. It's beyond the scope of this video right here, but I just wanted to let you guys know that it's possible. So I'll press enter to accept the default, which again is to take up the entirety of the disk or cause the partition to take up the entirety of the disk. And as you can see right here, a new partition has been created. The type is Linux and the size is 16 gigabytes. And if I press P again, we can see that we have a partition. The partition is located at /dev/vdc1. Now, if any of this confuses you and you want to learn even more about storage when it comes to Linux, I have entire videos that goes over this, so I won't repeat anything here. But if you follow along with me, then actually everything should go just fine. Again, if you wanted to create additional partitions, I'll leave that up to you. But for right now, we're just going to work with this one partition right here. And even though when I typed P and pressed enter, it's showing us a partition, there actually isn't any partition on the disk just yet. What we're seeing right here is a summary of what the result will look like if we finalize our changes, but we haven't done that yet. So in order to actually finalize changes, we could type W and press enter. But before I do press enter, just know that creating a new partition layout on a storage volume is going to completely wipe out that storage volume. In our situation here, it doesn't really matter because we just set up a brand new volume and that volume doesn't have anything on it in any way, shape, or form. The only reason why I mentioned that is because if you're using the fdisk command against the wrong volume, that will result in data loss. So just make sure that you're targeting the correct storage volume, and then you can go ahead and continue. On my end, I know this is the right selection here, and everything looks correct to me, so I'll press enter to finalize the change. And once we do that, fdisk will close and bring us back to the command line. So now, if I type lsblk again, the output looks a little bit different. Before, we only had VDC, we didn't even have a single partition, but here we can see that we do have a partition, VDC1. And that's basically how partitions are named in Linux. We have a number at the end of the device identifier that identifies the partition number, and it's as simple as that. However, simply having a volume isn't enough by itself. What we'll need to do is actually format the volume just like we would with any other storage volume. So if you've ever set up a storage volume on a server before, well, this is going to be the exact same process here. So to format the volume, here's what I'll do. I'll type sudo, and then I'll type mkfs, short for make file system, dot, and then I'll type the file system type that I want to create on that volume. I'll just keep it simple and use extended 4 or ext4 for short. That's pretty much the default file system when it comes to Linux. There's other file systems as well that I cover on the channel, but what I'm going to do is just leave it as simple as this because extended 4 is a great choice if you don't have another preference. Next, what we'll do is we'll target the actual partition that we've just created. And that'll be located at /dev. And then the last part, you'll want to make sure that it matches on your end. In my case, it was VDC1. but you will want to make sure that you type the right device identifier right here because this will destroy data if you target the wrong volume. In my case, I know that this is correct, so I'll press enter. And that happened very quickly. The new partition has been formatted. And now it's actually ready for use. Well, almost. We have to mount the partition on the file system, basically attach it to a directory. That way we can actually target this volume and save data on it. And to do that, we actually have a /mnt directory, short for mount, and there's currently nothing in there. Technically, you can attach this volume to any directory that you want. However, the /mnt directory is one of the designated directories on the Linux file system for this purpose, so that's why I'm going to utilize this. Now, if you need additional information about this, what I'll do is leave a card right about here, and that card will take you to a video that goes over some of the concepts around the Linux file system, including the purpose for the /mnt directory along with other directories. Now, what we'll actually do to facilitate the storage volume and attaching it to the file system or mounting it, what we'll do is we'll create a brand new directory for that purpose. So I'll type sudo mkdir. We want to create a directory that's underneath /mnt. And underneath there, what I'll do is just call it storage1. Now the name doesn't really matter. You could call it whatever you'd like, but we do need a directory to attach the volume to, and this is the one right here that I'll be creating for the purpose on my end. And as you can see, we have the storage1 directory there underneath the /mnt directory. So now that we have the directory that we intend on using for our volume, how do we go ahead and mount that directory? Well, I'll show you that in just a moment, but before I do, a command that I want to introduce you to, in case you weren't already familiar with it, is the df command, or the disk free command. Here, I'm going to use it with the -h option, which is short for human readable. And the -h option will help us understand the output better because it's going to actually show us the results in megabytes, gigabytes, and things like that. You know, basically the things that we're used to seeing. So, I'll go ahead and execute this command. And as you can see, there's a lot of storage volumes here. We can ignore all of the temp file systems and the loopback devices as well. And that leaves us with /dev/vda1. We can see that that's mounted at /, that's the root file system. So what we can glean from that is /dev/vda1 is the primary storage volume for the operating system of this particular instance. So we definitely don't want to mess with that. But we also don't see VDC1 at all on this list, and that's because we haven't mounted it yet. So what I'll do is clear the screen, and I'll show you how to go ahead and mount the volume. So to do that, what we'll type is sudo, and then mount. We want to mount /dev/vdc1, the volume that we've just created. And what we want to do is mount that at /mnt/storage1. Now I didn't get any output here, but also I didn't see any errors either. So if I run df-h again, let's see how the output will differ from when we ran it the last time. As you can see here, we have /dev/vdc1 at the very end. On the right-hand side, we can see that it's mounted at /mnt/storage1. We're using just 1% of the space, and that 1% is completely inconsequential. We haven't actually saved anything there, but we could clearly see that we have 15 gigabytes of storage free. So that's what we have available to work with. But more importantly, that volume is mounted to our server. We can actually use it for whatever the purpose is that we've created it for. Now, if I go back to the browser here, there's something that I want to make sure that you are aware of. Now, as you already know, we attached the volume to the instance, and then we formatted it, we also mounted it. But there's something that we can't do, and what that is the fact that we can't mount this particular volume onto any other instance. Since we attached it to our restored instance, then that instance owns this volume. Basically, that means that a volume can only be attached to a single instance at a time. And that might seem like a limitation that you would rather not have, but then again, the concept makes sense when you think of the volume as a hard disk, or at least a physical hard disk. With a physical disk, you have to physically connect a cable to connect it to a server. Now, you can't connect more than one cable to a disk, so the one-to-one relationship between the disk and the server kind of makes sense when you think about it like that. Just like with a physical server, where you can only connect a single cable to your disk, we can only attach the storage volume to a single instance. So just keep that in mind. Now what you can do, obviously, is disconnect the volume from the instance and attach it to another instance. In fact, you could do that as many times as you want. The volume doesn't have to be permanently mounted to an instance or attached to an instance. You can, again, disconnect it and then attach it to another instance. Just wanted to point that out. Anyway, let's go back to the terminal and we'll continue on. Okay, so before we continue, I think it's important to understand how that might help us. What exactly is the benefit of that concept in the real world? Well, when it comes to most organizations, there's usually a policy in place known as a retention policy. This basically means that the organization must retain data for a specific amount of time before destroying a disk or deleting a virtual disk. Now, even if an organization doesn't have such a policy, local laws might mandate a retention policy anyway. As an administrator, it's crucial to understand if your organization has a retention policy in place, as well as any local laws that may exist that might mandate retention policies. I'll leave it up to you to understand what your local laws are and to ask your management team. I just wanted to make sure that you were aware of that. And in that example, a retention policy might play out when you decommission a server. Maybe you set up a compute instance and it's very useful, but at some point in the future, maybe you replace it or you no longer need that particular instance anymore. If that's the case, you can disconnect that particular volume from the instance, delete the instance, and then retain the volume in case you need it later. If you do, then you could attach it to another instance if you need to pull data from that particular storage volume. After the retention period has lapsed, if you no longer need that volume, then you can go ahead and delete it. And not only that, another use case that might be useful when it comes to storage volumes and being able to transfer them from one server to another is when you want to transfer data. For example, let's say the Linux distribution that you're using has released a new version and you want to upgrade to it. And perhaps you want to spin up a brand new instance with that new distribution version, but you also want to transfer data from the old instance to the new one. Now, of course, if you're a seasoned Linux guru, then you probably already know that you could use something like rsync to transfer data from one server to another over the network. Depending on your network setup, though, that might actually have some bottlenecks. That might take a while, especially if you have a ton of data on that volume. So it might actually be easier and a lot faster to disconnect the volume from the old server and then attach it to the new one. At that point, you don't have to worry about transferring anything over the network. You could actually just attach the entire disk to the new server, and that's it. So that's yet another benefit of this particular style right here, being able to create multiple volumes. It could even aid in transferring data as well. You know what? Let's go ahead and see this in action. What I'm going to do is type sudo nano. I want to create a text file. I'm going to create a text file on the storage volume that we've just set up. So for that reason, I'll type the path as /mnt/storage1. If you recall, that's where we mounted the storage volume. And underneath there, I want to create a file called testfile.txt. I'll just use that file as an example. Inside this window right here, what I'll do is type hello world. I think that should be good enough for the example, so I'll save the file and then close out. Now at this point, the storage volume is still mounted. We know that because when we type df-h, you can see that it's mounted. It's listed there at the very bottom. If it wasn't mounted, then it wouldn't be shown here in the output at all. Now the lsblk command will show the volume even if it's not mounted. If it is mounted though, we will see underneath the mount point column a path. We do see a path right here, /mnt/storage1, so again, we know that it's mounted. So to unmount the storage volume, which is the first thing that we'll have to do before we disconnect it in OpenStack, we could run sudo, and then umount. That's short for unmount. The absence of the n is intentional. And then we'll type the path. So in my case, /mnt/storage1. I didn't receive any errors. And if I run the df command again, we can see that the storage volume is no longer listed here. And if I type lsblk, we can see that VDC1 is still listed, but unlike last time, there's no mount point now. Again, the lsblk command will show all storage volumes even if they're not mounted. df-h, on the other hand, will only show volumes that are mounted. So basically, that means that we have successfully unmounted the storage volume. And if we list the storage of the directory that we actually mounted it to last time, which was this one right here, it's empty. So even though I created a text file on that volume, it's not located right here because the volume isn't attached to this directory anymore. So the file still exists, it's on the storage volume, but again, we've unmounted it, which is telling the server that we are not going to be using that volume at the moment, so we've removed it from the system. Anyway, what I'll do is disconnect from this instance here. That takes me back to my local command line. And then let's go back to the browser. We have the blog data volume right here, which I realized I actually forgot the L in blog, but we'll ignore that. Anyway, I'll click the drop-down arrow right here, and I'll click Manage Attachments. So right here, we can see that just like we've instructed, the volume is mounted right here to this instance. So what I'll do is click Detach Volume, and then I'll confirm it. Now notice that the status has gone from in use, it said in use like this one does, but it's changed to a status of available. That means that this particular disk or virtual disk is available. I can attach it to any other instance, or at least any other instance that's within the same availability zone. Here we see the availability zone is Nova, so I have to make sure that I'm attaching it to an instance in that same availability zone, otherwise, well, it's not possible. Now, I only have that one availability zone anyway, so that doesn't really matter. I just wanted you to be aware of that. Anyway, what I'll do is click the drop-down arrow again, and again, I'll go back to Manage Attachments. And as we can see, it's not attached to anything right now. But when I drop this down, I'll choose the other instance here. Previously, we attached it to this one. So what I'll do is attach it to this one. So I'll click Attach Volume. Now the status has changed to in use. So I'll go back to the compute section here and then instances. And here's the instance that we are using for this example at this point. And if I scroll down, we can see that the volume that we created earlier is now attached to this particular instance, and it also has the same device identifier. Now it's not showing the partition number here, that's okay. It's just showing the actual disk identifier only. So everything looks exactly as it should at this point. So let's grab the IP address to this instance right here. I'm going to connect to it via SSH. And then back here in the terminal, I'll just paste the IP address here at the end. So there's the command that I'll use. And now I'm connected. If I type lsblk, you can see that we have /dev/vdc1 right here on the list. And as an aside, the device identifier will not always be the same. If this particular server already had another volume, and maybe that volume was also named VDC, then this one here would be VDD, and then VDE, and then VDF, and so on. So the next available device identifier is what's provided to the storage volume when we attach it. But since I haven't attached anything to this instance either, then that's why it has the same name, so we'll just go ahead and go with VDC. So again, just like last time, I'm going to make a directory that we'll be using to mount that volume. And I'll just give it the same name. It doesn't really matter, but I'll just make it consistent. So now we've created that directory. Then after that, I'll mount it the exact same way we did last time. So sudo and then mount /dev/vdc1. And we're going to attach it to /mnt/storage1. Now, before I actually press enter on this command right here, what I'll do real quick is just show you that that directory is, well, empty. That makes sense. We haven't mounted anything to that directory just yet. So as you can see, it's empty. So here's the command right here that we'll use to mount the storage volume. And, well, I didn't get any errors. You can see that it's listed here at the very end. And just like last time, when we run lsblk, we can see that a mount point is applied to that storage volume, so it must be mounted. In fact, Last time this directory was empty because the volume was not mounted. Since I mounted it, we have the test file right here. If you recall, we created that on the other server, and the volume's not going to change from one server to the next unless you change it yourself. So all the contents of that volume will come along for the ride when you attach it to another server. And just to be sure, we can see that the contents of that file is exactly as it was on the other server. So, as you can see, this could be a very useful method when it comes to transferring data from one server to another. And it also helps you make sure that you're within compliance of any data retention policy that might exist. Now, something that's really important to note here is that one command that I didn't run this time, that I did run last time, was the mkfs.ext4 command. I didn't run that this time around, and that's because if I did, then that would have wiped out everything on that volume. You only want to run the mkfs command the first time, and that's the only time that you'll need it. Of course, if you wanted to empty out a volume, you could certainly do that, but I'm not going to do that in this case. I just wanted you to be aware that we didn't format the partition this time because that would have wiped out everything, and then that goes against the purpose for it. Now, at this point, we've created a storage volume, and we were able to mount it. We were even able to actually save a file on it. There's two types of storage when it comes to cloud computing. We have block storage, and we also have object storage. Now, first of all, let's talk about block storage, so that way you'll understand what that means. Even if you've never heard of that term before, you're actually more familiar with that concept than you might think at first. Block storage is literally the type of storage that we've been working with so far. When we created VM instances within OpenStack, the boot volumes for those instances were block storage volumes. When it comes to physical computers and servers, if you install a physical hard disk, well, that's a block storage volume. Basically, a block storage volume is a disk or virtual disk that can be formatted, mounted, and data can be copied to it and read from it. So basically, block storage refers to a hard disk. Now, object storage, on the other hand, is a relatively newer concept and is quite popular when it comes to cloud deployments. Unlike block storage volumes, object storage doesn't have a maximum amount of space. A traditional hard disk will have a particular amount of storage space that you can utilize. We created a 16 gigabyte volume earlier, so in that case, we can't save more than 16 gigabytes on that one volume. Object storage, on the other hand, can store as much data as you want with no limit. Of course, limits can still be imposed, but to keep the explanation simple, you can store as much as you want with object storage. A particular object storage volume isn't actually referred to as a volume, but instead a container or bucket. This doesn't necessarily imply container as in a Docker container, but instead a container that's able to hold data. Another difference when it comes to block storage is that these are not formatted. In fact, when it comes to object storage, there's no file system at all. A bucket is essentially a key value pair. Every file that you save within object storage has a name, and then there's the data within the file itself. So basically, the relationship is name-data. And yet another difference when it comes to object storage is that a server instance isn't necessary at all. These containers can actually be used with or without an instance. In fact, let's create a container right now. But first, what I'll do is create a simple HTML file. So what I'll do is actually disconnect from the server instance. I want to create this file locally on my local workstation. So I'll just use nano. So I'll just name this file index.html. And this is going to be super simple. So that's not exactly the most complicated example of an HTML file, but it doesn't need to be. This is just an example. So I'll save the file and close out. So let's go back to the dashboard here. And then down here, we have Object Store. So click on Containers right here. We're going to create a bucket. I'll click this button right here to start the process of creating it. For the container name, I'll just call it test_container. I think that's good enough. And in this example, what I'll do is actually make this public. I'll click Submit. And it says success, so it looks like it created the container. And sure enough, here it is. So what I'll do is click on it. And as you can see here, there's nothing inside this container. So if I wanted to add a file to this container, what I could do is click this icon right here. It looks like an up arrow. I'll click Browse. And then right here, I have the index.html file that I created. So I'll click on that and I will select it. Let's upload the file. And as you can see, the index file has been uploaded to the container. And if we click right here where it shows the name of the container, you'll see that we have a public access link that's cleverly named link. So I'll just right click on this and I will copy the link. And let's paste that link into this tab right here. What do you think is going to happen? Well, let's paste in the link and we'll see. So here we have the entirety of the URL that's attached to the actual container that we've created. And as you can see right here, we have a file name of index.html. And what that's telling us is that index.html is inside that container. So what we can do is append the name of the file to the end of the URL that you see right here. And this is how we can actually get public access to an object within our object storage container. And check it out, it says hello world. And it's no coincidence that that's exactly what we typed into the index file. As you can see here, we can view the index file as if it was a web page by viewing the public URL of the container along with the file name. And there's many use cases here. For example, you could set up a maintenance page if your website is under maintenance. You could point your DNS to this right here. And what that'll do is point your users to the maintenance page if that's something that you wanted to set up. Or perhaps you want to serve a static web page to your users, and if that web page is not going to see any changes or very few changes, then it might just make sense to add the files for that website to a container, as we've done here, and that'll actually be easier than maintaining a full web server just for one static web page. But perhaps a more popular use case for object storage is storing backups. And actually, object storage is a great place to store your backups. And there's even utilities out there that understand how to use object storage for that purpose, so that's yet another use case for object storage. And with that, episode number 3 comes to a close. Thank you guys so much for checking out this particular episode. And also, thank you again to OpenMetal for making this entire series possible. But you know what? This series is far from over. There's still 3 more episodes coming that might even be out already, depending on when you're watching this. Either way, be sure to subscribe to LearnLinuxTV for the latest in Linux, and I really appreciate you checking out this episode. With that said, I'll see you in the next episode as soon as you're ready. And again, thank you so much for checking out this series, and I'll see you again next time.